Good morning, all of you. Happy New Year. Now, we are going to start examples on free body diagram. We know that what is free body diagram. In previous lecture, we have understand about the free body diagram. In that case, just recall it whenever anything that is supported by whatever support, we are going to remove that support, and instead of that support we are going to consider reaction that given by the support, and we are calculating that reaction, how much reaction that support will give us. That is called free body diagram. Means simply we are just remove the support, and instead of support putting down the reaction over there, and we will make the body free from support. That is called free body diagram. Now here we are going to finding out the reaction due to support with the help of Lami's theorem. So what it called? For the understanding, we are going to take some examples on the free body diagram. First example, a sphere weighing 10 Newton is hung as shown in figure. Find tension in the rope and the reaction of wall. This is our vertical wall. This is sphere which is hung by the rope, that is indicated over here, and the weight of this sphere is 10 Newton. So just simply consider that this support will be moved downward due to gravity. So tension generated in this rope as well as this sphere will be trying to move leftward, but this wall is going to support of this sphere. So the wall is giving us the horizontal reaction. So it is somewhere over here, Rw. A weight 10 Newton is downward, and a tension is in the direction of upward, in the direction of rope. So this is our three forces. First one is weight, and that is given. Unknown reaction Rw due to wall, and tension in a rope T. We are going to finding out these unknowns. So basically first we have to finding out this angle, and angle must be calculated with the help of x and y axis. So here it is 30 degree with vertical, so here also it is 30 degree with vertical. So this is 60 degree, this is 90 degree, this is 90 degree, and this is 90 degree. Now as per the Lami's theorem, we must have to calculate the whole angle between two forces. So this is 120 degree, this is 90 degree, and this is 150 degree. So what is Lami's theorem told us? If we are going to talk about the T, then opposite angle must be taken in the form of sine and divided by t. So t upon sine 90 is equal to Rw upon 150 sine 150 and 10 upon sine 120. So whatever we are going to talk, it is something like this using sine rule or else Lami's theorem. T upon sine 90 is equal to Rw upon sine 150 is equal to 10 upon sine 120. Now we are going to take a pair of these two with one known force and another is unknown force. So first we are going to take these two, and secondly we are going to take these two. So T upon sine 90 is equal to 10 upon sine 120. So we will finding out the T as a 11.55 Newton. And secondly, we are going to finding out Rw and pair of these two. So we will get Rw, so reaction due to wall. Now from this Lami's theorem, we can calculate the unknown reactions. Now another thing, that is a load of 100 kilonewton is hung by a means of rope attached to a hook in horizontal ceiling. This is our ceiling, and 100 kilonewton force is hung by a simple rope. What horizontal force should be applied so that rope makes 60 degree with the ceiling? Right now this angle is 90 degree. We are going to pull this rope in horizontal direction in the form of this angle from 90 to 60 degrees. So we have to pull down this rope towards the horizontal direction. So here it is 60 degree and P1 is somewhere over here and the weight is here. Draw the free body diagram. This is our free body diagram, and calculate the horizontal force and tension P and T we have to finding out. Also calculate minimum force required if angle of rope with the ceiling remains 60 degree. And in another case, what we want? Minimum force. So whenever we are going to finding out the minimum force, the angle must be 90 degree. So here we are going to maintain 90 degree, but here also we have to maintain 60 degree. So from this, again we have to finding out the another force. So from these two FBD, we have to calculate the unknown forces. So here what happens? It is 60 degree. So here it is also 60 degree. This is 30 degree. This is 90, 90, 90. So again P upon sine 150 is equal to T upon sine 90 and 100 upon sine 120. From this we can calculate like this. So we are going to take pair of these two. So we will get P1 and pair of these two we will get T1 like this. Now minimum force P required. For the minimum force we must have to maintain this angle 90 degree, right? So it is 60 degree and this is 30 degree. So again P2 upon sine 150 is equal to T2 upon sine 120 and 100 upon sine 90. So from again we will get P2 and T2 with the help of two pairs. So P2 is equal to 50 kilonewton. It is a minimum force, and a T2 is equal to 86.60. Here, due to this just simple modification, we will reduced. We can reduce the efforts. Another case, a cylindrical roller having weight 1000 Newton is resting between two smooth surfaces inclined at 60 degree and 30 degree with horizontal as shown in the figure. Draw free body diagram and determine the reactions at the contact points A and B. This is our cylinder and it is rest in this V channel groove. Angle of this is 60 degree, this is 30 degree, this is contact point A, this is contact point B. So this cylinder having weight 1000 Newton. Here support A going to give reaction Ra, which is passes through the center of this point. So it is Ra. Now the angle for this Ra, this is 60 degree, reaction is always perpendicular, so it is 90 degree. So this is 30 degree with the horizontal, so RA having 30 degree with horizontal. Same way RB going to pass through the center of the cylinder. So here it is 30 degree, so it is 60 degree, so 60 degree somewhere over here. Now this is 60, so it is 30 degree, it is 60 degree. Now we will get the Lamis theorem from these three forces, and we will get unknown forces RA and RB. So RA upon sine 150 is equal to RB upon sine 120 is equal to 1000 upon sine 90. Now we will take two pairs. So RA is equal to 500 Newton from this, and RB is equal to 866 Newton from this. So all of you, I think you can understand that this is the simple. Just we have idea about the how to draw free body diagram. Then afterward we can calculate all these things in this form of simple way. Now another case. An electrical lamp in street is having 50 Newton weight is suspended by a wires of 4 meter and 3 meter length. The horizontal distance between two fixed points are 5 meter A and C. This is 5 meter, from which two wires were suspended. It is 3 meter and this is 4 meter. Finding out the tension in both wires. Here we are going to finding out tension in these two wires. So simply what we are going to consider, if this is 5, this is 3 and this is 4. So what is the angle? So as per the Pythagoras, we can finding out this angle as a 90 degree, right? So this is making our right angle triangle, and we can calculate also three angles of this triangle. So once we will get the angles theta 1 and theta 2, afterward we can make the free body diagram. So this is theta 1, so here it is theta 1. This is theta 2, so it is theta 2, and this is 90 degree. That thetas must be calculated by us like, for three side of triangle ABC, 5 square is equal to 3 square plus 4 square. So beta is equal to 90 degree as per the Pythagoras. Now tan theta 1 and tan theta 2 is also calculated from the rule of right angle triangles. So we will get theta 1 and theta 2 from there. Now just make the equation of Lamis theorem. T1 upon sine 126.86 is equal to T2 upon sine 143.12 is equal to 50 upon sine 90. So we will take the pair of these two and we will calculate the T1 and T2. It is 40 and 30 Newton. So it is very much simple. Another most important case, a uniform wheel of 600 diameter. So diameter of this wheel is 600, so radius is 300. A weight of that wheel is 1000 Newton, so it is somewhere over here. Rests again a rectangular obstacle 150 high. This is our obstacle and having 150 high. Find the least force required when acting through center of the wheel. Here we are going to finding out the minimum force, means least force Why we are going to finding out this force? We are going to just turn this wheel from here to here. So what minimum force required to take this wheel from here to here? So what is going to do? This is our wheel. This is a 1000 Newton force. This is 300. This is 150. So here this is also 150 mm and this is 300 mm. So reaction must be passing through the center of this wheel, and the minimum force we are going to finding out, that is 90 degree from here. Then and then we will calculate the minimum. As we finding out the minimum force, it must be at right angle, means at 90 degree. So if we finding out this angle theta 1, then we can calculate all the things. So theta 1 is equal to 30 degree. So here it is 30 degree. This is our 90 degree, right? So it is 60 degree. Again this is 60 degree and this is 90 degree. So from this figure we can take the equation like P upon sine 120 is equal to R upon sine. Here 150 is equal to 1000 upon sine 90. Now we can calculate the unknown force P and reaction. But here one important note, that is, for the force to be minimum, it should be perpendicular to reaction. That we know very well. So here from that equation P is equal to 1000 into sine 120 upon sine 90. So it is 866 Newton, or reaction 1000 into sine 150 upon sine 90. So it is 500 Newton. Clear everybody? Okay. Now another. Till this example, we are going to understand about a single free body diagram. Now whatever and what happening when the it is more than two free body diagrams. So it must be considered that it is in equilibrium. A weight of W is suspended from the ceiling with the help of ropes as shown in the figure. Find the value of unknown weight. This is our simple system, and whenever the two force system are there, then it must consider that this system is in equilibrium. For the calculation of unknown weight W, we must consider that this system is in equilibrium. Then and then it maintains the shape this kind of. So it is 45 degree, it is 60 degree. So it must be Z section. So it is 60 degree and here it is 30 degree. Now we are going to finding out the two free body diagram for B and for C. So what happening? Consider equilibrium of C. First we are considering C force. So here it is 60 degree, it is 30 degree, and this is 30 degree, it is 60 degree, 90, 90. So it is free body diagram of joint C. So we are going to finding out the from the our Lami's theorem, FCD upon sine 120 is equal to FBC upon sine 150 is equal to 100 upon sine 90. So from these two we can calculate FCD and FBC. Now for equilibrium of B, FBC is equal to FCB and it is 50, that we know. Now here another two unknowns, FAB and W. So from again Lami's theorem, W upon sine 165 is equal to FAB upon sine 60 is equal to 50 upon sine 135. So from this, we can calculate the unknown weight W and force FAB. So whenever this kind of system, it must be considered that it is in equilibrium. For the equilibrium, we are going to take condition that FBC is equal to FCB. So unknown forces in the rope, that is equals. Then and then we can calculate this unknown weight W. Clear? Okay, fine. So now thank you. From next lecture we are going to start our new topic. Thank you very much.